Hello student, welcome to AK Virtual Math. This is question number 16 based on inequalities, and sometime it is also called as LPP, linear programming problems. So in this question is asking write down all the inequalities that define the region R. So how we can define this region R with the different inequalities. So how many inequalities we required to define this region R. So we'll see how many boundaries are there. So in this region, we have this one boundary here. This is another boundary. This is another boundary, and this. So total we have here 4 boundaries. So we need 4 inequalities to define this region R. So let's see how we can get these 4 inequalities. To find out inequalities, first we have to find out the equation of the line of the boundaries. So let's see first this boundary here, this line. So equation of this line is parallel to the x-axis and it intersect y-axis at 4. So we can just write y is equal to 4. So this is the equation of this line, and similarly here the equation of this line is this line intersect y-axis as 3. So equation of this line will be y is equal to 3. And now let's see this equation of this line here. So this line is parallel to y-axis and it intersect x-axis at 2.5 or 2.5. So the equation of this line will be x is equal to 2.5. So this is very easy to find the equation of the line which is either horizontal or vertical. So if it is horizontal, so y is equal to, we have to see where it intersect y-axis. So we'll just write y is equal to 4, y is equal to 3. If some line is vertical, so we have to just see where it intersect x-axis. So we have to just write x is equal to 2.5. Now this fourth one, we have to find out the equation of this line. So this line is neither vertical nor horizontal. So we have to use this formula. We know that the equation of the line, straight line, can be given as y is equal to mx plus c. So we need m. M is what? The gradient of the line. And c is the y-intercept, where it intersect y-axis. So y-axis here it intersect at 0. So c will be 0 here in this case. But we have to find out gradient. What is gradient? So to find out gradient, we know that gradient is equal to what? Rise upon run. So if you'll find out gradient, so simple formula for the gradient is equal to rise upon run. So here let's see what is rise and what is run here. You can take any 2 point on this line. If I'll choose this point here, so this will be run and this will be rise here. So run is 1 and rise is 2. So gradient will be m will be equal to rise is 2, run is 1, 2 upon 1, that is 2. And c, y-intercept here where it intersect y-axis, that is 0. So c is equal to 0. So the final equation of this line will be y is equal to 2x. X is m is 2, so 2x, and c is 0, so nothing, just y is equal to 2x. So see, we got the equation of all the 4 boundaries. Now we have to write down the inequalities. We have to convert these in inequalities. So first line, if I'll see this, so this is y is equal to 4. If I'll take region R is above this line, so y will be greater than 4. And if region is below this line, so y will be less than 4. So here this region is below this line, so we can write this here, y is equal to less than 4. And if this line, these boundaries are full line, solid line, then we have to write y is less than or equal to y, because the point on this solid line will be also included in that. So this will become first inequality. We have to just write y is less than or equal to 4. So because this line is solid line, not the dashed line or not the broken line. Now let's see this second one. In second inequality, that y is greater than 3 because the region R is above this line. So above this line means y should be greater than 3. And this is broken line, dashed line. So the y is equal to 3 will not be included. This boundary will not be included in this region. So we have to just write y is greater than 3. Now we'll see this third boundary. So this is here x. If this region is right side of x of this line, so we'll write x is greater than this 2.5. But here region is left side of this line, so we have to write x is less than 2.5. And this line is solid, so we have to write x is less than or equal to 2.5. Now this fourth inequality. So here we have y is equal to 2x. So we have to see whether line is this region is above this line or below this line. So what we have to write accordingly, we have to write this y is less than 2x or y is greater than 2x. To check it, we can simply take one point here. So if I'll take this point below this line, suppose okay, let's take this point here. You can take any point in the region as well, anywhere you can take this point, so it will be okay. So here if you'll see, at this point x is equal to 2 and y is equal to 1. So if I'll put it here, so y is equal to 1 and here x is equal to 2, so 2 times 2, that is 4, so 1, and here we'll get 4. So which sign will apply here? This of course 1 is less than 4, so means here you have to apply this y is less than or equal to 2x, because this line is solid line. So finally we have to write y is less than or equal to 2x. So see, we have written these four inequality. So this is how, if any inequalities, a problem based on inequalities are given like this, any region is enclosed with these different boundaries, so how we can define this region with the help of these inequalities. Thanks for watching, guys. Please like, subscribe and share this video with your friends. Drop your questions or doubts in the comments. I'll be happy to help.